you can see that it's rotating like a bolt. The thread, cutting threads are moving down. And the other piece of the puzzle is that the worm wheel, which the worm itself rather, also has a helix on it, as you can see like this. And so you have to cut the teeth such that they are the result of a combination of those two helix angles. So the angle of the thread, that's a bit like that, and the angle of the helix on the worm, which is sort of a bit like that. And you do that by skewing round the top of the hobbing machine to the right angle. That's something that's easy to say and apparently very hard to do. We've done a load of modelling in a spreadsheet and we thought we had the right answer, but I had several bad starts. But actually this test piece, which you can actually probably see has been cut with two different sets of teeth on it by accident, well, as part of the examination process, now actually does sit square on the worm when it's engaged. Hard to see in this light and with my fiddly holding, but it's pretty much there. The principal issue you're trying to deal with is you've got to get the sign of the angle for the two helixes correct, and I kept on making mistakes on that. So the second one of those, the second set of teeth I cut on there, it's an undersized gear wheel, that's why it looks a bit odd. Turns out that you had to rotate the top of the hobbing machine by 1.9 degrees clockwise, and you can just about see down here that's pretty much where we got it set, 1.9 by eye, and it appears to be working. So we're going to have a go on this piece of phosphor bronze. It's actually a bit narrow for the job, but it's all we've got left in stock, and prove to ourselves that we've got something that works. Let me get it set up and I'll show you it cutting. So the first bit, which we talked about before, is the business of setting the cross slide, this feed that's got the gears on it that are not currently engaged, so that we get the teeth in the middle of the blank. Now you can see that because I did a slightly sloppy job of boring the blank, it's cutting more on one side than the other. But you can see on the thin side we've pretty much got those teeth in the middle now, and I think that's close enough to start. So we're going to put some down feed on. Yes, I know the engraving on the vertical downfield is a bit off, but about 2 seems to make a sensible cut, and you can see it here it's starting to cut now, and it's starting to form the teeth. Of course you sort of feed down every couple of rotations of the blank because we're cutting all the teeth at once, the beauty of hobbing. And that's going to take me 5 or 10 minutes to get down to the correct depth. So I'm going to pause you again while we have a little go at that. A bit farther along now, and you can see the teeth are starting to form quite nicely. The video makes it look as though the hob is turning clockwise, whereas in fact it's actually turning anti-clockwise because that's the way it's set. And it seems to be cutting quite nicely down. This is actually in LG2, whereas I think it ought to be in 660 phosphor bronze. But at this stage of the project, I think this is good enough. What we're trying to do is to prove that we've got a working arrangement before we go mad. I've drawn out a gearbox housing, and I'll show you that in the post as well. Right, a little bit more carrying on, and I'll come back again. Okay, we're getting pretty close to the end now. We've got to go for a 1.65 inches depth of cut, and we're pretty nearly there. I've just put a little bit more on, and I'm just waiting for it to sort of cut the last out. It's gone pretty quiet now. I'm going to measure it again and have a final check. Yeah, that's saying we're about right. So we're just measuring the depth of tooth effectively with a vernier gauge, push down onto the teeth, and that's saying 168. So within the scheme of my accuracy on this job, that's about it. But as you can see, the gear itself is looking quite nice. If we just set it to run quietly, you can see over here we've got the motor drive, then we've got some gearing on the back here to speed up the hob spindle, and then all this gearing at the back is producing the right rate of rotation for this worm and wheel to turn the blank to give us the 21 teeth that we've decided. 21 to 1 will give us a track speed of something like 3.5 mile an hour. Not blindingly fast, but then it is a shunter. So I'm quite pleased with that. I think it's okay. If we just stop it once more and balance the worm on top, you can see that it balances square. So that says to me we finally got the computation right, and that 1.9 degrees, 1.91 degrees was actually it, but I can't measure that accurately, clockwise on the slide was what we needed. Okay, thanks a lot.